Good morning, good afternoon, good evening, wherever you're watching me from. This is your favorite tutor, Osman Tutor, where chemistry is made easy for every student to learn and understand chemistry better. Today we are looking at a special topic, very common and very simple topic, yet so many students are having issues with this topic on how to apply the information on this particular topic. And what is the topic? The topic is the periodic table. The periodic table is what we're looking at today. And before I go on, let me give you a short breakdown or short overview of the periodic table. Now, when we say the periodic table, to a layman, they will think it's a normal table. It's not table. Please, when we say periodic table, it simply means the arrangement of elements in order of their increasing atomic number. The arrangement of elements in order of increasing atomic number. I'll be showing you the periodic table chart as we go on in this lesson. Now, briefly, I also want to talk about that statement. That I want to bring out a clause from that statement that the periodic table is what is the arrangement of elements based on the atomic number. That particular statement is what we refer to as the periodic law, which states that the properties of elements is a periodic function of their atomic number. So meaning that when you see an element, how do you look at the element? What do you see the element maybe acting like? What is the reaction of that element? What are the properties of that element? That property of that element, it is a function of its what atomic number and the periodic table. Now let's quickly take a short view of the periodic table chart. Just a Here we have the periodic table chart. This is the periodic table chart that you can see here. Now, this periodic table shows us the display of all the elements. This particular periodic table gives you the uses of the element, the applications, and all those things. The application of the element and the group they belong, the period. So now let me quickly start with the first classification of the periodic table this morning, and I will be talking about the groups and the period. The periodic table can be, further classified under groups and period. What is a group and what is a period? What is a group and what is a period? Let's go. Now we say a group. Now looking at this particular purple column here, you can see this particular column is the group one element, contains the group one element, and we call that group one element, we call them alkali metals. Alkali metals. Now, there's a reason for calling them alkali metal. Simply, let me just tell you this. Now, when this element reacts, they form with water, they quickly form solution that is alkaline in nature. So they are alkaline metals. So now this element they belong to group one. So in the periodic table, we have a total number of 8 groups in the periodic table, while we have total number of 7 periods in the periodic table. Now, like I said, the periodic table is this group shows the vertical arrangement, from top to bottom, and the periodic table from top to bottom. So in group one, we have the element lithium, we have sodium, potassium, rubidium, we have cesium, and francium. Please, I want you to take caution at this point. That since hydrogen in group one does not mean that hydrogen belongs to group one. Hydrogen is just placed in group one for convenience's sake. So hydrogen does not belong to any group in the periodic table. So I move on to group two. The group two elements, these are the alkaline earth metals, and we have the elements beryllium, magnesium, calcium, strontium, barium, and radium in group two. So now someone will say, how about this? Okay, now I'm just going to tell you something now. We need to take caution at this point. This particular portion we are seeing, they are special groups of elements, and they are called the transition element, the transition metals. These are all metals, they are all metals. Why are they called that transition? I will talk about it. So let's move on to the next group. I can say this is group one, the alkali metal, And here is group 2, the alkali earth metal. And here we have the group 3 here. The group 3 are the aluminum family. We have the boron, the aluminum, gallium, indium, thallium. So these are group 3 elements. And we move on to group 4. These are the carbon family, the silicon, germanium, tin, and the lead. And group 5 we have the nitrogen and the phosphorus family. We have the nitrogen, the phosphorus, arsenic, antimony, and then bismuth. And we move on to group 6. These are the oxygen family, the chalcogenes. So where there are oxygen, sulfur, selenium, tellurium, polonium, and then we move on to group 7. This is the halogen family. Group 7 is another unique family on the periodic table. So we have the halogens, that's fluorine, chlorine, bromine, iodine, astatine. These are the group 7 elements. Now, lastly, but not the least, we have the noble gases. These are the group 8 elements. And at the right side corner here, we have helium at the top, followed by neon, followed by argon, followed by krypton, xenon, and then radon. These are the groups of elements in the periodic table. So, sometimes we say we have group A and B. So we have group 1A, 2A, then you move on to what? Aluminum as group 3A, 4A like that, and so on and so forth until you get to group 8, which is referred to as 18. Now here, these are the B sets. But because of the nature of this element, they are specially placed in that group. So we are not going to count them, we are not going to refer to them now. They are special placed element there. And they are called the transition element due to their special properties, which is completely different from every other element in the periodic table. Okay, now we move on to the second classification, which I said period. Don't forget, I said the first one is called group, and the group is what? The vertical arrangement from top to bottom in the periodic table. That's the first classification I'm talking about. Now the second one is what? The period. The elements in the periodic table can also be viewed from left to right. Left to right, you can see where I'm standing. This is my left, this is my right. So from left to right. Now let's move to the top. Look at hydrogen at the top left, and helium at the top right. So if I move from hydrogen and I move to helium straight, that is the period 1, the first period. So that is the horizontal arrangement of elements in the periodic table. And what does this tell us? Now, the period shows you the number of electron shell, the number of electron shell that an element possesses. Okay. Now, I'll still go back to group later on because of something I need to let you know about group of elements. Now, looking at it again, the second period, I said we have 7 periods. So the second period is from lithium up to what? To neon. And the third period, we have sodium to argon. And the fourth period, potassium up to krypton. And the fifth period, we have rubidium and moving on to what? Xenon. And we have the sixth period, we have cesium, and we move on to what? Radon. And the seventh period, we have the what? The francium. Now, moving on to what? To the deuterium here, which contains the actinide and the natinide series. Okay. Now we have periods. We have 7 periods all together in the periodic table. So let's just take a short break now as we look at some things about the periodic table critically. So, having seen the periodic table chart, now, like I said, we have the alkali metal, then 2, we have the alkaline earth metals. Now, this is the first group 1, this one calls group 1, and this is group 2. Then all together we have what? 3, 4, 5, 6, 7, 8. And here is what? We have the aluminum family here, aluminum family. That's the 3. And in group 4 we have carbon family in group 4, carbon family in group 4. And in group 5 we have the phosphorus or nitrogen family, phosphorus there, family, and group 6 will have the oxygen family, oxygen family, and I call this one chalcogenes. Chalcogenes. Okay. Now group 7 we have the halogens, that's the chlorine family, halogens. Then we have the noble gases, these are the rare gases. Just say inert, they are inert element, rare gases. Now, so these are what? Group 7, this is group 7, and here is what? Group 8. So this is group 3, this is group 4, and group 5, and then group 6. So these are just a short breakdown of the periodic table. Now, the period I was talking about, I said we have total number of 7 periods. So the period is the result, those are shown on the chart already. Now let's now look at another classification on the periodic table. Before I move on, I don't want to skip this information so that you will not be confused as you watch the video. Now, I said something, I said for period, the period of element tells you the number of electron shell that is having. Electron shell, let me use the dot and cross diagram for the electron shell. Now I have, for hydrogen, hydrogen has just one proton, and the nucleus of hydrogen has just one proton. So that means I'm going to just draw one shell. So because hydrogen is having just one shell, so it belongs to what? To period 1. Period 1. Because it has just one electron shell. So hydrogen belongs to period 1 because what? It has just one electron shell. Now, likewise helium. Helium, though having 2 electrons more than electron, which is more than hydrogen own, but because it's still having the same number of electron shell, so hydrogen and helium belong to the same period on the periodic table. Now let's look at another example to make it a little bit better and clearer. Now, what if an element belongs to period 3? What does that tell you? Or what if an element is having atomic number of, like, say 3, which is, example is lithium. Lithium is number 3. Now, what period does lithium belong to? How do you know this? That, how do you tell us the period that lithium belongs to? Simply just do this operation. Just write the electronic configuration of lithium, or you draw the electron shell, no matter which one you feel like doing. Those one will tell you the period that lithium belongs. Now let's look at it. Lithium, based on our energy level, lithium electron will occupy just 2 shells. Out of those shells, the first one is called K shell, and the second is what? L shell. And so we have, out of 3 electrons, I'm going to place 2 under K shell, remaining just 1 electron. So the remaining 1 electron now will move straight to what? To L shell. Now, when you look at it, this is a shell, and this is another shell. So, since lithium is having 2 electron shell, we said lithium belongs to period 2. Period 2. Okay, what if an element has atomic number of, like, let's say 17, for instance, 17? How do you know which period it belongs? Okay, let's see. Looking at elements with atomic number 17, which period does it belong? How do you tell us the period? If they ask you in an examination, like I told you, just do a simple operation. Now, here is the atomic number of chlorine, which is 17. What do? Simply break it down, write the electronic configuration of chlorine, and that solves the whole problem. Then, what is the electronic configuration of chlorine? We have, like I told you, don't forget this to help to guide you. The KLFN, the shell is at the energy level of shell. So energy levels or the electron shell. just say electron shells. Okay, so out of 17 electrons, I am going to place 2 under K. Why 2? Why can't I put everything under K? No. Each of these each of the electron shell, they have the specific number of what they can occupy, the capacity of electron that they can what contain. And so for K shell, the maximum it can take is just 2 electrons out of 17 for chlorine. Whatever the element is, the maximum number that K shell can occupy is just 2. So like I said, K will take maximum of 2. Now, for L will also take what? Maximum of 8. It has the character of taking 8 electrons. Now, based on the our electron rule, normally we are supposed to put 18 here, 2, 8, 18. But to avoid confusion or ambiguity, we just have to what? Put it as what? As 8. So instead of writing 18, I put 8 here. Likewise, N. So I put 8 as well to avoid confusion. Normally, if you follow the basic electron rule, so it will be 2, 8, 18, and 36, like just like that. Alright, now coming back to chlorine. Chlorine has a total number of 17 electrons and 17 protons. So that makes a complete neutral atom. Alright, now for K shell, like I said, take 2 out of 17. What do you have left? You have just 15 left. So out of 17, I'm taking 2 out, and that's why I bring it here. 2, then I place a comma there. Remaining 15. The remaining 15 now, like I said, since L shell has the capacity of taking 8, so I take away 8 from that 15. 8 from 15, I have 7 left. So this is the 8 I took from 15, and I'm having what? 7 left. So the remaining 7 now is going to move on to the next shell. Meaning that the N shell will have nothing there. So nothing will be here. So then it means that the electronic configuration of chlorine is 287. 287 using the energy level. There are other ways of writing it. I will go into that in the next video. So at this point, the electronic configuration of chlorine is a 287. Hence, we're talking about period. Which period now does chlorine belong to? Now, this thing can also be represented under dot and cross diagram, what I was talking about before, so that you know what electron shares is all about. So the K shell, let me just draw it here. Let's say this is my K shell. Then the next one is what? Is L, and the next one is L, and lastly I have the N. Now, if you look at it, my K shell has what? 2 here. So I place 2 here, 2 electrons here. So I have I can use my cross here. I'm going to use dot as well. So then for the L shell, I have 8. So I'm putting 8 electrons here. 1, 2, 3, 4, 5, 6, 7, and 8. Now I'm left with just 7. So the 7 now, electron comes here. I start 1, 2, 3, 4, 5, 6, and 6 and 7. Now you notice that the last shell has nothing in it. So to avoid confusion, what do? I remove it. So here I'm having just 3 electron shell occupied by electrons in the atom of chlorine. So the atom of chlorine shell, I have just total number of 17 electrons, and those electrons they occupy just 3 shells, the K, the L, and the M shell. So because of that, I have the first shell, there are total number of 3 shells. 1, 2, and 3. So 3 electron shell, 3 electron shell. shell. So hence chlorine belongs to period 3. Period 3 because it has just 3 electron shells occupied by its electrons. This is how you can determine which period an element belongs to in the periodic table. So I think this one is a little bit clearer. Don't forget. Now let's now move to the other classification of elements in the periodic table. At this point, I will now go back to the periodic chart that we used earlier on. This is our periodic chart. Now, the next classification I'm moving on to now is called the families of elements. So I will use the word blocks. So I will classify the elements based on the blocks to which they belong. You know, if you go to an estate, you have blocks of flats. You know, they may arrange them in any form, in any format. So the same way, when you look at this periodic table, you notice that some elements, even though they don't have the same atomic number, but they have their color is being colored with same color. You have this one all purple, you want this one sky blue, you have this one green, you have this one light green, you have this one yellow or orange, whatever you call it, and so forth. So we use that color to separate these particular families of elements. Now, the first block I'll be talking about, you know, is the S block. But let me just give you a breakdown. In total, we have about 4 blocks. We have the SPDF, the blocks. These are the blocks we have on the periodic table. We have the S block. Why are they called S block? Now, the S block elements are those elements that have their valence electrons in the S orbital. Again, the S block element are the element that has their valence electron in the S orbital. Then what is the valence electron? The valence electron is the number in the outer electron shell of that particular element. Let's give an example so that you can understand this one better. Let's start with the group 1 element, for instance. The group 1 and 2 elements, they belong to the same block and they are called S block element. So we can pick any of these elements in group 1 or group 2, whether lithium, beryllium, sodium, magnesium, potassium, calcium, and so on and so forth. So we can take any of them, and so we write their electronic configuration to show that they actually belong to S block. So let's go and do that now. And you can pick your pen and paper and follow me as I go on in the lesson. So welcome back. Let's look at some examples of the S block element and their electronic configuration. Why they are so called S block element. S block element. Now, like I said, the valence electrons of this element, you know, fall in on the S orbital. So let's go. For lithium, we have lithium has just 3 electrons, and so for the atomic orbital, we'll be using the SPDF notation to enable you to understand this particular concept now. And so I will say for this one, let me just give you a short overview of this. So just try and look at this. We have S, L and P, D, and then F. So if I'm correct, use this one now. I have 1S, 2S, 2P, 3S, 3P, 4S. So I'm going to stop at this level and we have a 3D. But I'm going to stop at this level for the first 20 elements. Now we'll take time to analyze the transition element that most of the electrons fall on the D orbital. So for elements like lithium, let's look at where the electron fall into. Before I go on, quickly let me explain something here. For S orbital, the maximum number of electrons on S orbital is 2, whether 4s, 5s, 6s, 7s. So if I'm using this particular notation, for S orbital, the maximum number of electrons it can occupy is just 2. Then for P, P has 3 suborbitals, so it has minimum of 3 and maximum of 6 electrons. So then for D, I have minimum 5 and maximum of 6. Oh, sorry, of 10. Then F, we have minimum of 7 and maximum of 14. So then for S is just minimum of 1 and maximum of 2. Okay, I think that's a little bit clear. Now let's consider lithium. I'm going to follow this particular notation here, so I'm making use of that. So don't forget. Now for S, for lithium, for the first one, it's going to take 2. Then I will transfer the remaining electron to the next shell. So if I go to write for lithium, I have 1s, and I said s can take maximum of 2. Since I'm having more than 1, I will not put 1 here because I have more than 1 electron. But if I don't have up to that, like the case of hydrogen, if it's hydrogen for instance, it's going to just be 1s1 because hydrogen does not have more than that. So that is the maximum number of electrons of hydrogen. So for lithium now, for lithium is going to be 1s2, then the remaining electron, 1 electron, will move on to what? The 2s orbital. So I have 2s1. If you add 2 and 1 together, it will give you 3. So this is how we write the configuration. And we now say that this element, they are called S block element because look at the valence electron. From your KLF, you notice that lithium is 2, 1. So this one is the valence electron. This is the valence electron. Valence electron. So this is the valence electron, and the same valence electron fall on the s orbital here. So because it fall on s orbital, so we say lithium belong to s block. So it's an s block because its valence electron fall on s orbital. Let me give you 2 more examples, then we'll move on to the next one. Okay, now for the p block now, the p block element. Okay, before I go to p block element, let me just give you 2 more examples. Like I said, sodium and calcium, magnesium, they are all there. So let me take group 2 element now. Let's say magnesium. Magnesium, which is number 12. So if I'm to write it using my energy level, just use 2, 8, 2, which is 2 plus 8 plus 2, that's 12. So now I want to show you why magnesium also belongs to the S block. So I'm going to change the notation now. I'm going to use my SPDF notation. This will tell you that magnesium truly belongs to the S block family. Okay, now let's go. Count of the 12 electrons that are available. Like I said, I'm going to use this operation. So the first one I'm going to take is my 1s. And my 1, like I told you, anything s, the maximum you can take is just 2. The maximum of electron is what? Is just 2. So I go on to say 1s2. Out of that, it remains 10 electrons. Then the next one is what? 2s. So I bring my 2s here. 2s. Since it is the same s, it occupies 2 as well. So I have 4 already. Now remaining 8. So after 2s, the next is what? 2p. So I put on my 2p here. And don't forget, p can take maximum of what? Of 6 and minimum of 3. But look at magnesium. I have exhausted just 4 out of 12. So I still have 8. That means there is enough electrons for p orbital to be occupied with. So that means I can still get the complete orbital for magnesium. So I have 6 here. So 2p 6. Then the next one, now I'm having just 2 electrons left. Now after 2p is what? Is 3s. So my next electron move to 3s. Don't forget, s has the capacity of just taking only 2. So I put the 2 here. Let's sum it together. You have 2 plus 2, that's 4, plus 6, that's 10, plus 2, that's what? 12. This is the normal ground state configuration of a magnesium. And look at the valence electron. Valence electron. Valence electron is on S orbital. So because the valence electron fall on S orbital, we said that magnesium belongs to S block family, the S block element. So that is it. In the last example, let's take any one like potassium. Potassium, take potassium for instance. Potassium, that's number 19. So let's use the energy level first. We use the 2, 8. Remaining what? Remaining 9. So, 8 again, and then 1. Now, let's now go and confirm and see why potassium also belongs to the S block by writing its electronic configuration using the SPDF notation. SPDF, sorry, this is F, this is F. So, don't forget, we have a total number of 19 electrons for potassium. And so, out of this 19, the first one, the first orbital is S, that's 1s. So, I put it on here, 1s, take 2, followed by 2s, take another 2, followed by 2p, taking what? 6, followed by 3s, taking 2, and followed by what? 3p. This is 2 plus 2, that's 4, that's 10, that's 12, 3p, 6, and 4s, 1. So let's sum it together to see. 2 plus 2, that's 4, plus 6, that's 10, plus 2, that's 12, plus 6, that's 18, and plus 1, that's 19. Now come to potassium. Here is the valence electron. As you can see, the valence electron of potassium fall on what? On S orbital. So that is why group 1 and group 2 elements, they are called S block elements. So potassium is what? Belongs to the S block element. I believe this one has been able to open your eyes to how you can write the configuration of element using the SPDF notation and also the energy level or the dot and cross diagram to write the electronic configuration of the element. I will still make a video on how to properly write all these electronic configuration one after the other. Now let's move to the next part of the lesson before we close for today. So quickly, let me just round up this lesson by showing you the P block element. I'll give just one example of the P block and the D block because of time. I have to make it short so that it will not be boring. You not be bored too much. So quickly, the P block element, they have their valence electron in the P orbital, and that's why they are called the P block. Let's take an example. For instance, like I showed you on the periodic table, that the element like aluminium, and the boron, they all belong to what? The P block. Let me start with the boron. The boron for family, for instance, boron is atomic number. That's atomic number what? Number 5. So you have, sorry, yes, atomic number 5. And so for boron, you notice that out of these 5 electrons, you have 2, 3. So if I use our SPDF rotation, don't forget this SPDF rotation, don't forget. So I use my 1s2, 2s2, and then 2p1. You notice here that this valence electron of boron first on p orbital, and so because of that, boron is on the p block. So that valence electrons of boron is on what? On p. So you have, I know, don't be confused with the two s there and the two pl. We actually take, because the valency of boron is 3, so we have 3 as the valency. And when you look at it, the last one here is what? Is p. So p orbital happens to be where the last electron of boron fall into. So boron belongs to what? To the p block. To the p block. Then for the p block, let's look at scandium because of time. Scandium is number 21. You have 2, 8, 8, 3. Now in this case, I will just put this as there: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d1. Let's add it together. 2 plus 2, that's 4, that's 6, that's 10, that's 12, and that's 18, and that's 20, that's 21. So look at the last electron of scandium. The last electron of scandium belongs to, so the last electron of scandium fall on the d orbital. So because of that, scandium is a d block element. So in the subsequent video, we'll be looking at further, configuration, writing of electrical configuration of all other elements. I will seriously deal with the transition element, which normally gives students, challenge during examination. And I will tell you how you can also apply all this in other reaction that you may come across in your study of chemistry. So this morning, I want to encourage you to just don't stop where I stopped this morning. I still want you to go further and research, and please don't forget to send in your question, and I will, I will answer your question. I'll send you feedback quickly, and very good feedback, no matter how. Also, don't forget to please subscribe to our channel, like, and then, please share with your friends, and also tell your friends to subscribe to the channel, so I can give you more better video lessons as we study your chemistry. Thank you very much. I remain your favorite tutor, Osmart Tutor. Thank you.